Uniton lets you control the Unity game engine from Python. You can use it with any Unity project. Just go to the GitHub page, download the Uniton DLL, and drop it in the project assets folder. When you launch the game, you can see that Uniton is running. To interact with it, pip install Uniton, open up a Python REPL, and import Uniton. The Unity engine class gives you full control over the engine. You can precisely control timing by pausing the game and manually stepping through each frame. By default, each step will advance game time by 40 milliseconds, but will execute as fast as possible in real time. The Unity engine object also represents the root namespace for all C# classes and sub-namespaces, such as system or even custom ones, such as the one for this card game. The scene attribute allows for easy access of all game objects and components in the current scene. Let's get the card's rigid body and make it move by setting its velocity to a constant value at each step. Nice. Now that we've seen how to get data into Unity, let's see how we can get data out of it. Of course, one of the main reasons to use Unity is for rendering. The queued renderer class helps us to do that in a non-blocking and easy way. We initialize it with the main camera in the scene and give it a resolution. And to get frames, we simply call render. All right. For the last part of this demo, let's pull it all together and render a whole video using a compiled version of this Unity project. We can run the compiled version just by passing the path to the binary to Unity Engine. After recreating the renderer, we create an image.io video writer to encode the frames. We choose 25 FPS because our time step is 40 milliseconds. Now we use the same loop from before, except that it's now including the renderer and video writer. We can see that the rendering works fine. It's just not very fast because we're still rendering to the screen too. To fix this, we can disable the main camera and the game manager. It now takes less than a second to render. Of course, the rendering speed depends on many factors. In this particular example though, we rendered, sent over the Python, and encoded all at 330 FPS.